Hey guys, for those of you interested in mechanical engineering, raise your hand. Oh, yeah, thanks guys, that was awesome. That was like better, way better than I was anticipating. Everybody usually is like, hey, I'm going to be a computer scientist, or I'm going to go like wire things up. But really, mechanical engineering is where it's at. You get a little bit of everything, get a little bit of electrical, get a little bit of computer science, and get a whole lot of things that move and don't move. So who has stuff in their project that you eventually have to make move with a servo or a DC motor? Yeah, so roughly 2/3 of you. Exciting. I'm soliciting feedback.
Once it works.
Great. So like once you get there and once you figure out how to get there?
Yeah.
Awesome. Who has to manufacture something?
Like,
yeah. How many hands are we?
What does that
see,
mean?
like,
What is manufacturing?
Jairus, I'm so glad you asked. What does manufacturing mean? What do you think it means?
To like make something
From what?
from scratch or through, yeah, I don't know.
In our terms, it's going to be modifying original materials. Right? So in any sense, it is a process, is a value-added process. Make sense?
Yeah.
You good with that? What does value-added mean? Kind of an ambiguous term. Do you want me to define that? Yeah.
like it makes it more useful.
Bingo! We're adding useful properties to it. So does me just standing here playing with a marker, is that a value-added process?
I mean, you're pretty, so.
Thanks, Chris. But again, that's not value-added. This marker isn't doing anything besides allowing me to fidget with it. That is not a value. That is not enhancing the usefulness of this object or my intentions. However, manufacturing should always be thought of in terms of value-added processes. We want to ensure that any change or process we are invoking on a material or an object is enhancing the usability of it. So who can think of a manufacturing thing? We can just keep this super broad, an idea, a concept, a process. What would you manufacture?
If you have like a bunch of metal, you can cut it into like your chassis.
Awesome, so we're cutting things, cutting metal for chassis. Yeah, so we're taking, sheet metal from the hardware store and we're cutting it into a specific shape. So we are doing a process to add value to it. Fantastic. What else?
Turn wood into the frame of a house.
Sweet! Yeah, that's a great one. What else? I saw another hand.
We're gonna say making a box. It's like a simplified version.
I would agree. What can you make that box out of? Perfect. What else? Cardboard. Yeah. Right? You gotta. Everything around us is manufactured, and so it's really important to start at the basics. A couple of you have talked to you about engineering drawings, and that's really like the heart and soul of manufacturing. That's how you, as engineers, and for those of you that are going to go to the far superior side of mechanical engineering, will convey your ideas to your fellow engineers and machinists. Now, machinists are persnickety, and they're going to want to make sure that they don't ever have to talk to you, because that's just how it is. That's just the reality of life. They're going to want to minimize interactions, because what you should be able to do is effectively communicate your design ideas in a single set of drawings. So you should be able to hand them a set of drawings and a bill of materials. Who here has done a bill of materials? That was the most slow reaction for everybody in this room. You all know you have, which is great. It's great practice. So you should be able to hand a machinist your bill of materials and stacks of drawings for whatever you need to manufacture and say, go, and then write me a bill. Sound like fun? What about all that work that went into those drawings? Where do we have to start with that? Any ideas? Where do we start? Brian, where do we start? Where did you start?
CAD software. In a CAD software.
Ah, CAD. What does CAD stand for? Anybody have an answer? That was lackluster. Can we try that one more time?
Computer
Nice.
Computer what drawing?
Yeah. So, who here's worked with CAD before? What software platforms have you guys worked with? Onshape. Nice. One of the best. What else?
Inventor.
Inventor. Yeah. What else? AutoCAD? AutoCAD, SolidWorks, yeah. Awesome. So those are all software packages that make our lives easier, right? They allow us to design some incredible things. Who here has an iPhone? Yeah, that was all done in software packages in CAD, right? You have to make sure it's all going to fit together when you manufacture it. So you're going to bring together all these like 300, 500 components and make sure that when you actually go to manufacture all of the parts and pieces and you want to put the final screws in, that they fit, right? Because that would be real terrible if, say, you put a caster wheel on a vacuum robot and your 10mm screw actually needed to be 6mm. Who here's had that problem? Yeah, okay. So Andrew pointed out today that in the manufacturing process, some equipment would no longer allow him to properly mount his battery. But how did you have to answer that question? What did you have to do?
Look at the file.
Ooh, what was that file? Like what generic file was that?
STL file.
Yeah, and what do you view STL files then? So you were able to envision somebody else's design concepts in a CAD file. Excellent way to communicate ideas. So once you go through this great design process and you figure out how everything's going to fit together and work, what do you have to do? Somewhere between, I thought of all these cool things and made it in a modeling program, and here are all my drawings and my bills of material.
You create a drawing file in your CADDing software, and you import the part, and then you make the 4 images of it.
Yeah. So what's that drawing file called? What would you call that? It is a drawing, but there's a specific, I mean, so is this. Yay, there's a drawing. Is that what I want?
No.
What kind of drawing do I want?
A mechanical drawing.
A mechanical drawing? Yep. What else could that be termed?
An isometric sketch.
Ah, it's getting to the specifics. I like it. We'll get there. It's an engineering drawing. We're all going to be, hopefully, engineers, right? So you want your engineering drawings. You want your drafts, your designs, your concepts to be in a communicable format. If I look at some fancy, as Bates put it, isometric drawing, and you have this fancy little box, and we're going to have a hole through here, and have some stuff here. We're going to have a call out here at M3. That's the hardware that won't work. Are you going to know what to do with that? Who here could look at this box and be like, oh yeah, Eric, I know how to make that? No? Nobody? Yeah, so we have to figure out a better way to communicate this. So Bates hit on something pretty cool. We've kind of developed a system. And we're going to come back to that box. But you start with an isometric drawing. Who can define for me what an isometric view is, besides Bates? Takers? Takers? Somebody said they're good at drawing earlier. Anybody? Brian?
Well, I can't draw it, but it's kind of like drawing it in 3D on a 2D page.
Awesome. Gives you an idea of the depth, the width, and the height for a specific part in a drawing without on a 2D plane, right? Who here looks at a 2D plane all day? You all do. You all stare at screens all day. That's a 2D plane. Sometimes video companies will mask that with 3D glasses or something, but you're still looking at a 2D plane. So we have to communicate our 3D ideas on a 2D plane. Easier said than done. At least I found that out real quick. How does one convert fancy drawings from 2D to 3D, or 3D to 2D? Either way. I can't rely on you for every answer, so we're going to hold your thoughts. So we're going to start with that isometric drawing. We'll start in 3D and go out to 2D. Trying to think of something easy enough that we can all talk about. So, what kind of drawing is this? This is a 3D representation on a 2D plane, which means it's a awesome, fantastic. So this is our isometric view. What's next? Right? Now I kind of want to see, like, Eric, you drew some funny lines over here. And, I don't know, you got some stuff going on. Like, it's weird. I don't get it. What's going on? What do I want to see out of this? Yeah?
Every case has affected.
Sweet! Yeah, that was key. So earlier somebody mentioned, oh, you have 3 drawings. Sure, standard, yeah, I'm going to end up with 3 drawings from this isometric view. But Lawrence hit on a phenomenal point. What you actually want is a view of every affected face. So that if there was stuff going on inside of here, we'd have to build another isometric view of what was going on and extrapolate further. But for this one, thankfully, we can just take a look at what's going on here. So who can tell me, if this is my isometric view, what's next?
An orthographic view?
Ooh, Bates, you're hitting the vocab just very well today. Can you define orthographic for me?
It's a view of a face, and then it has the rest of the things as well.
Yeah. Yeah, so a great way to think of this is you've already defined what dimension here. What dimension can I see easily?
All of them?
Most of them, yeah. So
Most of them.
we're gonna take a dash over here, literal, and those are some dimensions that I can use to constrain my orthographic drawing. Sound good? We want to make sure that what you're looking at from your isometric is the same thing you're looking at from your orthographic, right? We want to make sure that you as an engineer are able to communicate that, hey, like, these 2 ideas are uniform across this, quote, invisible line. It's like the horizon. You need it, it's going to be there, but you're never going to draw it. I'm not an artist, so I really can't draw horizons, but that's for another day. So what face do we want to look at first?
Front.
Front. What do we want to define as front?
If you were looking directly on it.
So you're looking here, you're looking here, you're looking here, you're looking here. What? It's ambiguous. What do you want to define as front?
Well, you can just pick a certain face. So you can pick the, let's say the left. That one, yeah.
Here? Sweet. We can do that.
View.
My apologies. I made that mistake. That's our actual height. You good with that? Great. So, what do I have to draw here? Somebody kind of walk me through it.
You draw the face.
Sweet. What's next?
Once you've drawn the face, then you add in the other parts that you'd see from the perspective of looking at that face.
Fantastic. And how do I add those? Anybody know what these dashed lines are called? Well, I'm going to have you hold off for just a second. I know you know the answer. Any guesses? Bueller? Bueller? Anybody besides Lawrence and Bates and Brian and staff? Nobody wants to take a guess? Come on, guys. It's okay if you're wrong. Yeah.
Dash line.
They are dashed lines. You're right. It's wrong. Sorry. It's called hidden lines. Right? They're lines you can't see from this view. They're lines you can't see from this view. We good with that? Does that like make sense?
Yeah.
Great. So, come down to about there. We'll assume it's like 50% of the way. Those go all the way to the top. Yeah. We still have a face in there. Awesome. So those are hidden lines. Does that make sense? We're looking at it from this face. We following? Awesome. Are you guys like that tired? Whew. Okay. I guess we are that tired. Awesome. What's next? you guys are just going to answer all my questions today. So we'll just kind of keep going around between you three. Brian, since you're on my left.
So now that you have the front view, you're gonna draw the top view and the right view as like basically in orientation with that. So you draw.
So what do I want here?
So now you draw the top of it basically.
Cool. Sweet. Alright, where do those hidden lines go?
Down.
How far?
Into it.
Like all the way down from top to bottom.
Nice. Not quite, but
Oh,
it is poor drawing skills, not your perception. I agree. There's a slight gap here that didn't square the edge, so
oh,
I did leave just for that exact reason. That doesn't go quite all the way down, so we're gonna just leave it right there. You good with that? Yep. Great. This is an interactive discussion, so questions, comments, please send them my way. What else? What's next?
Another view.
Ooh, which one?
Let's do right.
Which
Side,
way's
right side from the original front view.
It's on you. You volunteered.
You draw it?
Absolutely.
Alright. Okay. I'm just as bad as already as you are.
Yeah.
So this view. Here. Is this one all the way at the end?
It's like,
Is that it?
no,
Does it go all the way?
that's the back.
I'm doing here.
Yeah, that's much bigger.
No.
Oh, wait.
No.
No, this is-
You said this is short?
Yeah, that one's short.
Yeah.
There you go.
Okay.
You know,
There.
So if we effectively communicated this drawing to you,
You need dimensions.
oh, yes, my favorite. What's the we have a question in the gallery.
Isn't there nothing
Where?
under it?
What about? Which view are we looking at? Here? Or here? Or here? We're looking at it if you took this and rotated it that way.
Right, should it be like
Back. Yeah, so if you were to look straight from this direction, it'll look like that. Now what's the difference between this solid line and this dashed line?
the solid line means you can actually see it from that perspective.
Sweet. Big key. Now next up, now that we've communicated our necessary information, we're going to dimension. Now, GD&T, who knows what that stands for? Oh, no, dude. It's gnarly, it's intense. Shy away from it. Actual geometric dimensioning and tolerancing has an entire code book of information and symbols and laws and rules that you have to follow. But for now, we can work on just providing appropriate dimensions. So, yeah.
Sorry, question. So it doesn't matter which side we use, right? Whether we use right or left.
Correct. As long as you can appropriate this rule of, I think there's a rule of thumb for which sides you select. The rule of thumb that I was always taught is adequately convey your thoughts. So that's why the 3 isn't necessarily going to be your best bet sometimes. But dimensioning, how do I dimension things? Anybody not Bates or Brian?
In units,
Great, what units do we want to use?
inches or meters.
Great, let's just use inches since they're here. That was the first thing you said. What's next? What do I want to dimension? What do I want to indicate? Sure. Lawrence, you had your hand up.
Like you would have like one line from like start and then another one at the end, and then you have a line connecting them, and then you have the number.
Okay. What's next? What am I missing? Label it? Yeah. So is that 1 inch? Is that truly 1 inch? What's our accuracy on that?
No one here.
Pretty poor. Did you just say nobody cares? Is that what I heard?
Yeah, we didn't know after that.
Is that different than that? Yeah. How about that? Yep. So, what's my most accurate digit here? Tenths, hundredths, or thousands?
The most accurate would be tenths or
Ooh. There's dissension among the rank. I love this. So when you say that you want it accurate to the thousandths, that means your most accurate digit is going to be the hundredths. Alright, so if you say this is going to be 1.000, that means you're going to be satisfied with that. There are other ways to dictate accuracy. That will be further in your machining careers. Just everybody should go learn how to use a CNC and mill and a lathe. But yeah, that's generally how you're going to dimension parts. That's kind of the gloss way to dimension parts. Again, you want to adequately convey how you're doing things. So here, what would I need to convey? Since we don't have that much time.
the length of the dashed lines.
Great. So how do I do that?
Well, you do that and put in the respective lengths, like, yeah.
Okay. But I'm still missing this part down here.
You already wrote it on the other
Are we
isometric
assuming this
view.
is square?
Well, isn't that the same length? The 1 inch is the same as the
top. So you're
top?
looking from the top.
Yeah, so this is already defined as 1 inch. So, well noticed.
And you also put the length of the other areas, like, or the width in this perspective?
That one?
Well,
Yeah.
put it
That one.
above.
That and.
And the drawer one.
Bait seems unsure. Other people
The
just are
one-
giving me blank stares.
The width of the dashed one should be put on top of the isometric view.
Nice. Well done.
Or wait, orthographic, sorry.
The one I was drawing on, I made a bad assumption. So that's generally how you're going to easily convey your manufacturing ideas. This is by no means perfect or intensive, but this is what I will need from you guys when you start manufacturing things. I need you to adequately convey your ideas. Jairus?
If we're using one of those programs above, do we just need to make one diagram, the isometric one? And then, because you can like just go to each face through the program, so do we just make one isometric drawing?
The best answer I can provide to you is as long as you can adequately convey your geometry through a single isometric. There might be times where you need to convey different sides or views.
Okay.
There's no hard or fast, yes, provide one if this, provide two if this. It is very much hand-wavy. Questions? Awesome, we have like a couple minutes, sort of. Wanted to take a quick open forum poll.